Welcome back everyone. I am Assistant Professor Milan Patel, ME Electrical Power System from Mahatma Gandhi Institute of Technical Education Center, Navsari. Today we will discuss chapter number 4, Estimation and Costing for Residential and Commercial Wiring from the subject Elements of Electrical Design having a subject code 31609118. Now, flow of contents for the today's video lectures are what is electrical load, different types of load, size of conductor. Now, GTU questions based on today's flow of contents are first, what is electrical load? Giving examples, classify different types of load. Was asked in June 2011 for the 7 marks. Now, second question, discuss in brief points to be considered while determination of the size of the conductor, which was asked in winter 2016 for the 7 marks. So these two questions will be covered in today's video lecture. Okay, now most IMP question, what is load? Define the types of load with its examples. So it was asked in GTU June 2011 for the 4 marks. So now first of all, definition of the load. So an equipment or a device that take or consume electric power is called electric load. So simple definition is there, an equipment or device that take or consume electric power is called electric load. And the second definition for load is that electric load means an equipment or device switch to take a current, and the impedance of the device is called the load impedance. The impedance of the load device is called the load impedance. સિમ્પલ ભાષામાં કહીએ તો જે કોઈ ડિવાઇસ કે જે ઇલેક્ટ્રિક પાવરને કન્ઝ્યુમ કરે it will called electric load. અને કરંટની ભાષામાં વાત કરીએ તો જ્યારે પણ આપણે સ્વિચ ઓન કરીએ કોઈ ઇક્વિપમેન્ટની તો ત્યારે એ ઇલેક્ટ્રિક કરંટને ડ્રોન કરે then it is called a electric load. Now example, for a 100-watt lamp and 43 milliampere current, the lamp having a power rating of 100 watt and current rating is 43 milliampere. So we can find the load impedance Z is equal to P by I. P by I. Where 100 divided by 43 into 10 raised to minus 3 is equal to 529 ohm. 529 ohm. For above example, we can say that the load will be either 529 ohm or 43 ampere. તો આપણે લોડને બે રીતે ડિફાઇન કરી શકીએ, કાં તો એ 529 ઓહ્મ છે અથવા 43 મિલી એમ્પિયર નો લોડ છે એમ. Now types of load. Types of load. So here main three types of loads are there. First one is domestic load, second one is commercial load, third one is industrial load. So types of load already discussed earlier in the previous video lecture, but domestic load, residential loads are considered as a domestic load. Commercial load, shop, restaurants, marriage halls, colleges, etc. will be considered under the commercial load. And industrial load, now industrial load is further divided in 4 types. Cottage industries. So in cottage industries, small machine shops, small lathe machines, etc. will be covered. Now small scale industries, and the range for the small scale industries are 1 kilowatt to 25 kilowatt. 1 kilowatt to 25 kilowatt. For example, sawmill, flour mill, oil pump, etc. etc. Now for the medium scale, medium scale industries. So the range for the medium scale industries are 100 to 500 kilowatt, 100 kilowatt to 500 kilowatt. And in medium scale industries, sugar factories, cotton factories are considered. And last one is large scale industries, and the range for large scale industries are 11 or 32 kV above, 11 kV to 33 kV above. Cement, chemical, steel mills, etc. will be considered under the high or large scale industries. And last one is agricultural or irrigation load. The rural irrigation in India depends on groundwater pumping or lifting water from tanks or nearby canals. So the main source of agriculture irrigation systems are the groundwater pumping and the lifting of water from the nearby canals, rivers, etc. etc. So for these types of loads, submersible pumps which require three-phase induction motor from 15 to 20 HP are used, and this type of loads are called agriculture load or irrigational load, which are used for the irrigation purpose. Now, important definitions which may be asked for 1 marks in GTU examination. So, first one is load factor. Load factor. So, the basic definition of the load factor is that the ratio of average load to the maximum demand during a given period is called load factor. Is called load factor. So load factor is given by average load divided by maximum demand. For average load will be calculated for the particular time limit, time period, and maximum demand is the same for the particular time period. And the value of load factor is always less than 1. Is always less than 1. Is always less than 1, and the average load daily is equal to daily energy consumed, which will be calculated in form of kilowatt hour, and it is divided by 24 will give you average load for daily. So energy consumed per day divided by 24 hours will give you average load for 1 day. Now second definition, demand factor. Demand factor. It is the ratio of maximum demand and the total connected load to the system is always less than 1. So the basic definition of the demand factor is that the ratio of maximum demand to the total connected load. Maximum demand divided by total connected load to the system is called demand factor. It is also less than 1. Now connected load. The sum of the continuous ratings of all the equipments connected to the supply system is called connected load. So connected load is nothing but the total sum of the all connected load to the particular system. And maximum demand, it is the greatest demand of the load on the system during a given period of time. So it is the greatest demand of the load on the system during a given period of time. So this is the maximum demand. Now diversity factor. This is also most common definition. Diversity factor. It is a ratio of sum of individual maximum demands of various subdivisions of the system to the maximum demand on the entire system. So it is the ratio of the sum of individual maximum demand. Sum of individual maximum demand of various subdivisions of the system to the maximum demand on the entire system. Greater the diversity factor means the lesser the maximum demand and better the load factor. So as the diversity factor increases, the lesser the maximum demand, and due to this lesser maximum demand, the load factor will be improved. Now diversity factor is equal to sum of all individual maximum demand divided by the maximum demand. Sum of all maximum demand, individual maximum demand divided by maximum demand. So the value of the diversity factor is always greater than 1. Is always greater than 1. Now another IMP question for today's video lecture is explain the factors affecting permissible voltage drop and the conductor size So the following points must be considered while calculating the size of the conductors. So main 3 points are there for the selection of the conductor size. First one is current carrying capacity. Second one is voltage drop across it. Third one is minimum permissible size. Minimum permissible size. So first one is current carrying capacity. First one is current carrying capacity, in which the conductor or wire should be of size sufficient to carry the maximum circuit current continuously without overheating. So current carrying capacity means the current conductors or wires should be of size sufficient to carry maximum circuit current without overheating, continuously without overheating. Now second one is voltage drop. Second one is voltage drop. So the voltage drop in a conductor or a wire depends upon the current flowing through the conductor and the resistance of the conductor. We know that the voltage drop is given by IZ. IZ, where I is the current flowing through it and Z is the impedance of the conductor particular conductor. And the resistance is, we know that the resistance is inversely proportional to the area. R is equal to rho L by A. R is equal to rho L by A, where A is the area. So we can say that the resistance is inversely proportional to the area, and therefore the voltage drop will be less if the area of the conductor is more. If the area of the conductor is more, as we increase the area of conductor, the value of resistance will be decreased, and due to this voltage drop Iz will be become less. Iz will become less because we know that as the value of area increases, the value of resistance decreases and voltage drop V is equal to Iz also reduces. Now volume of conductor is directly proportional to the current square. We know that the volume V for the particular conductor is directly proportional to the current I square. So volume of conductor is directly proportional to the I square, and we know that we also know that equation power is equal to Vi cos phi for the AC power. So we can say that I is equal to P by V cos phi. P by V cos phi. The put the value of I is equal to P by V cos phi and whole square as it is. So simply we can say that volume of conductor is directly proportional to the 1 upon V cos phi square. 1 upon V cos phi square. We remove the P because we know that the power value is constant for the particular system. So by changing the value of voltage and power factor, the value of the volume of the conductor will be changed. As we increase the value of the voltage, the volume of the conductor will reduces, and as we increase the value of the power factor, again we reduce the volume of the conductor. So this is the equation for the volume of the conductor. The permissible voltage drop in a lightning circuit is 2% of the supply. The permissible voltage drop in a lighting circuit is 2% of the supply voltage plus 1 volt plus 1 volt. So for a particular lighting system, there is a 2% of voltage drop plus 1 volt is applicable. And in case of industrial loads, the maximum voltage drop at the extreme and equipment should not be more than 5% of the declared supply voltage. For the industrial load, the voltage drop must be uh, a voltage drop or voltage variation not exceed the 5% of the declared supplied voltage. Now, last one is minimum permissible size. Minimum permissible size. So, the minimum permissible size of the conductor used in domestic wiring should not be size less than 1 to 1.12 mm copper or 1 by 1.40 mm in aluminum wire, where 1 indicates number of conductor and 1.12 and 1.140 indicates the diameter of that conductor. So in domestic wirings, the conductor size not less than the 1.2 means conductor number is 1 and the diameter is 1.12 mm for the domestic wiring with the copper domestic wiring, and for the aluminum conductor wiring, one conductor for 1.40 mm diameter will be used. So this is the minimum permissible size for the domestic wiring.